Hello everyone, I welcome you all in the next lecture of 12th class NCERT Mathematics. In this video lecture, we will discuss of exercise 5.1 question number 9 to 16. So without further ado, let's get started. So what first question says? The first question we have here, fx equal to the x upon mod x. If x less than 0, then we have this one piece, and if x greater than 0, then we have this one piece. Okay, so first of all, redefine this function. What we have, f of x equals to the, if x is less than 0, wait, first of all I will define this mod function. If x is less than 0, then we have minus x value, and if x is greater than equal to 0, then we have x value. So our above function will becomes f of x equals to the, here we have x upon minus x if x is less than 0, and if x is greater than equal to 0, then we have minus 1. So hence we have minus 1 if x is less than 0, and if x is greater than equal to 0. This is your f of x. From this one, if we combine these things, then what we are getting, we have f of x is equals to minus 1 for all x belongs to real number, implies that f of x is a constant function, and if it is a constant function, then it is a continuous function, implies f is continuous on R. Hence proof. I hope you understand this question. Move on to the next question. See, the 10th question says f of x equal to the x plus 1 if x is greater than equal to 1, and if x less than 1, then we have this one function. Okay, so yeah, all of the three question I will do this first one question. Okay, rest of the question you need to do because all have the same procedure. Now here they are also saying that discuss the continuity of this function. Okay, so what we have, f of x is equal to the x plus 1 if x greater than equal to 1, and if x less than 1, then we have x square plus 1. We have this thing. Okay, now again we have here, as previously we did some question from 1 to 6, in those question also and here also we have the same thing. Here see, the domain of this function is complete real number. Okay, and before 1 it is defined, at 1 it is defined, and after 1 it is defined. So we have how many parts? First part, second part, and the third part. Like that we will discuss its continuity. So here the first part came if x is less than 1. If x is less than 1, that means before 1, what we are saying, that f of x will be x square plus 1. Okay, and here we will say that if f equal to 1, observe that fx is a polynomial of degree 2, hence fx is continuous. Hence fx is continuous on minus infinity to open 1. Okay, now second thing is if x is at 1. Okay, if we are discussing at x equal to 1, then we need to discuss its LHL, RHL, and its function value at 1. So how we can find LHL? Limit x tends to 1 negative f of x, limit h tends to 0 f of 1 minus h we have, and here limit h tends to 0, wait, limit h tends to 0 Now by which function we need to find its value? By which piece we need to find its value? By the second piece we will find, because 1 minus h lies in the second piece, that is 1 minus h whole square plus 1 plus 1. We have this thing. Okay, now if we open it, what we get? Limit h tends to 0, 1 plus h square minus 2h plus 1, and we are getting here 2. Okay, now RHL, how we can find? Limit h tends to 0, f of 1 plus h. Actually the notation is limit x tends to 1 positive f of x. Limit h tends to 0, 1 plus h plus 1, and if you apply limit we get 2. So here, from here and here, LHL equal to RHL. What it implies? It implies that limit x tends to 1 fx exists and equal to 2. Now the third task is to find f of 1 value. See, f of 1 we can find by the first branch, that is 1 plus 1, that is 2. So here from this one and this one, LHL equal to RHL, LHL equal to RHL equal to f of 1. Hence the function is continuous at 1, implies f is continuous at 1. Okay, now we are moving towards the third part, that is if x is strictly greater than 1, for which the function is defined as x plus 1. Again we need to write the same thing. Again, f is a polynomial of degree 1, hence f is continuous on 1 to infinity. On combining first, second and third case, f is continuous on R. I hope you understand this question. So same thing we need to do in 11th and 12th. Okay, same thing, same process we need to do. Okay, this is your homework. If you have any doubt, then you can ask in comment. I will solve them again. Okay, now move on to the next question. The 13th question is same as that our first question. Is this function continuous by this one? Okay, same question we have. Okay, so here again we have see, observe, you can observe that this one, you have 1 here. Before 1 the function is defined by this one, at 1 also defined by this one, and after 1 defined by this one branch. Okay, so by three things we have, three cases we have. The first one case is here, second one case is here, and this is our third one case. Now the first one case we will discuss if x is less than 1. Okay, so if x is less than 1, then how we can proceed? LHL we need to find, LHL at any point. Okay, or we can say that f of x we have here x plus 5. We can say no need to by the usual method, we can use our result also na. F of x is x plus 5 if x less than 1. Since f is a polynomial of degree 1, implies f is continuous on minus infinity to 1. Okay, second case, if x equal to 1, then we need to check LHL and RHL and f of 1 value. Limit x tends to 1 negative, f of x we have, limit h tends to 0, f of 1 minus h we have, limit h tends to 0, f of 1 minus h. Okay, what is 1 minus h? 1 minus h find by the above one. 1 minus h plus 5, that will be 6. Okay, now we have RHL limit x tends to, wait, limit x tends to 1 positive, f of x we have limit h tends to 0, f of 1 plus h we have, and limit h tends to 0, what about 1 plus h? 1 plus h find by the second branch, 1 plus h minus 5, and here 1 plus h minus 5 we have here. Okay, so 1 minus 5 is minus 4 after applying limit. Okay, so observe that from both the equation LHL, wait, I will write it here. Observe LHL is not equal to the RHL, implies that limit x tends to 1 fx does not exist. Okay, DNE does not exist. So implies that P implies Q, not Q implies not P we have. If function limit is not exist at 1, then function is not continuous at 1. F is not continuous at 1. I hope you understand. The third part is here. Third part is if x is greater than 1, then function how they define? F of x is x minus 5. Okay, and here we can say that again f is, since f is a polynomial of degree 1, implies that, what we need to imply here? F is continuous. F is continuous from 1 to infinity. Okay, from 1 to infinity. If we combine all these cases, the first case, this is your third case. Okay, this is our second case. Okay, and this is our first case. If we combine all these cases, then what we are getting? That f is continuous on r minus 1. I hope you understand what I need to do here. Okay, if you have any type of doubt, then you can ask me in comments. I will reply there, and if a query is not resolved, then again I will solve. Okay, now move on to the next one. So here again we have a 3 question of same type. I will do any one of them. So okay, that I will do, this one I will do. The 14, 15, 16 you need to do by yourself. Okay, so here how they define function. The question number 14 we have here, f of x equals to the 3 if x is in between 0 and 1, if x is in between 1 and 3, and if x is from 3 to 10. So here 4, here 5. Okay, and you have a function like that. Okay, 1, 2, 3, and here 3, like this one. Okay, now how we can proceed in this question? See how we can proceed in this question. From 0 to 1, first of all we need to find the domain of f. Domain of f is close 0 to 10, you can observe. Okay, so on close 0 to 10, each element we need to check, is this function continuous or not continuous. Okay, so first of all we need to check, observe that again we have a 3 parts. Okay, we need to check at, not we have a 3 parts, actually we have a, I'll wait, what I will do, here you have, suppose it is your 0 at 1. Now open 0, close 0, open 1. Okay, then at 1, this is your second part, this is your first part. Okay, and after that open 1 to 3, open 1 to open 3. Okay, this is your third part, and here we have a fourth part at 3, and now open 3 to 10, open 3 to 10, open 3 to 10 we have a fifth part. Okay, actually 5 part we have for this question. Okay, so observe that first question. First part is if our x is in between, if our x is in between 0 and 1. Okay, if our x is between 0 and 1, then f of x equal to the 3. Okay, hence it is here, you can observe it is a constant function. If it is a constant function, then it is continuous function. Okay, now if x is equal to the 1, now for x equal to 1, for left hand side is defined by the 3, right hand side divided by the 4. So you can observe quickly that we can observe quickly that LHL equal to the limit x tends to 1 negative f of x, we have limit h tends to 0 f of 1 minus h we have, and here we are getting that 1 minus h, that is 3 directly. So LHL is 3. Now we need to find RHL. Now what we need to find? RHL we need to find here. RHL is limit x tends to 1 positive f of x, limit h tends to 0 f of 1 plus h, and here we are getting that 4 only. Okay, so implies that LHL not equal to the RHL, hence this function limit does not exist, and limit does not exist, hence function is not continuous at 1. Okay, why? So you understand, I think. Now if you have any doubt, then you can ask me in comment. Third thing is at in between, when x is from 1 to 3, again you can observe in between this one function is continuous, and if the function is continuous, then again it is function is constant, then it is continuous. Function is constant here. Okay, so it is continuous. Fourth one, if x is at 3, so again we need to find LHL. LHL is limit x tends to 3 negative f of x. Okay, so here we are getting that limit x tends to limit h tends to 0 f of 3 minus h, and if you apply this one, where we are getting where we are f of 3 minus h, find by the 4, that will be 4. Okay, so here we are getting 4. Now RHL, if you want to find, this is different one, this is also different one. RHL, if you want to find, RHL will be limit, wait, how we can find RHL? This is your LHL. Now how we can find RHL? RHL will be limit x tends to 3 positive f of x, limit h tends to 0 f of 3 plus h, and it will be 5 will come. What it will come? 5. Okay, so again LHL not equal to RHL implies that limit does not exist, and the function is not continuous at 3. Now the fifth part, when x is from 3 to 10. Okay, if x is from 3 to 10, then what we need to do from 3 to 10 is again function is 5, so implies that f is constant function, and if it is a constant function, wait, I will write as a constant function. Okay, if it is a constant function, then implies that f is continuous function. F is continuous function we have. Okay, I hope you understand. So from above all the cases, we can observe that f is continuous on close 1 to 10 minus, wait, 0 to 10 or 1 to 10, I'll check. 0 to 10. Okay, from 0 to 10, okay, minus 2 elements, 1 and 3, they are discontinuous. At how many points it is discontinuous? At 1 it is discontinuous, at 3 it is discontinuous. So f is continuous on this one, and f is discontinuous at 1 and 3. Okay, So I hope you understand all these questions. If you have any type of doubt, then you can ask me in comments. Okay, so thank you for watching.